Hello dear learners, welcome back to Fun Scholar e-learning series. My name is Rikta and we at Fun Scholar are committed to bring the best from the world of robotics and electronics to you. Hope you remember in the previous tutorial we have learned about diode. The link of the previous tutorial is in the description box. You can also watch it out just by clicking on the link popping up at the right top side of your screen right now. By the way, don't forget to like, share and subscribe to our YouTube channel. Today we are going to learn about transistor. The topic which we are covering today are where the transistors are used, what is actually a transistor, its terminals, different types of transistor and their symbol, working of transistor and its operating condition, and at the end of the tutorial you will be given a pro tip for better understanding of transistor. So do watch the tutorial till the end for getting the pro tip. Now, coming to the topic, transistors are the very important electronic component which is used in almost every integrated system. It is mainly made of silicon because of its high voltage rating, greater current and temperature sensitivity. Starting from computer, laptop, smartphone, transistors are used in almost every embedded system. Now, what is actually a transistor? Transistor is basically a semiconductor device that regulates current or voltage and acts as a switch for electronic circuit. It can also amplify a weak signal. In fact, amplification is the basic function of a transistor. So mainly transistors are used in switching and amplification purposes. It has mainly three terminals. The terminal which emits current called the emitter, the terminal which collects current called the collector, and the middle terminal is called the base. There are mainly two types of transistor, NPN transistor and PNP transistor. Whatever be the type, transistors are actually constructed by connecting two PN junction diodes. That is why I am suggesting you to watch the tutorial on diode that I have already made. The link of the tutorial is in the description box. Now coming to the topic, the first type of transistor which we are going to discuss today is NPN transistor, where two PN junction diodes are connected in such a way that the P region comes in the middle, where we know that in P region the majority of the charge carriers are holes, and this P region here works as the base. The two N region on both the sides of the transistor works as emitter and collector. Here we know that in case of N-type semiconductor, the majority of the charge carriers are electrons. Now this is the symbol of NPN transistor. The second type of transistor is PNP transistor, where the N region comes in the middle and works as the base, where the majority of the charge carriers are electrons, and the two P regions on both the sides of the transistor works as emitter and collector, where the majority of the charge carriers are holes. And this is the symbol of PNP transistor. Now we are going to discuss the working of transistor. In case of transistor, the emitter base junction of the transistor is connected generally in forward bias and the collector base junction in reverse bias. Now what is forward biasing and what is reverse biasing? In forward biasing, the N type of the semiconductor, where majority of the charge carriers are electrons, will be connected to the negative terminal of the voltage source, and in case of P-type semiconductor, where majority of the charge carriers are holes, will be connected to the positive terminal of the voltage source. But in case of reverse biasing, the N-type of the semiconductor is connected to the positive terminal of the voltage source, and P-type semiconductor will be connected to the negative terminal of the voltage source. Now let us discuss how the transistor actually works. When we connect the emitter base junction of the transistor in forward bias, the negative terminal of the voltage source is connected to the N-type semiconductor, where majority of the charge carriers are electrons. These electrons will be repelled by this voltage source and will be pushed from the emitter junction to the base junction. Now here in case of base, the majority of the charge carriers are holes. So electrons coming from the emitter, some portion of it will recombine with these holes and the rest will be attracted to this collector junction, because the collector junction is connected to the positive terminal of the voltage source. Now, so obviously the electrons coming from the emitter to the collector will start flowing through this path and will constitute the collector current IC. Now as the electrons are flowing in this direction, so current will flow in the opposite direction, and the current of the collector junction, we are denoting it by IC, start flowing from the voltage source to the transistor. Now in case of the base region, where the minority of the charge carriers are electrons, these electrons will be attracted to this positive terminal and start flowing in this direction and constitute the base current IB, which is very small in amount as compared to the collector current IC. Now that is how a transistor actually works. Transistors can be operated in three modes of operation. The first is the active mode of operation, which we already have discussed in the previous slide. In active mode of operation, both for the emitter base junction of the transistor is connected in forward bias and the collector base junction is connected in reverse bias. This mode of operation is used for mainly amplification purposes. In case of saturation, which is the next operating condition, both the junctions, that is the emitter base junction and the collector base junction, is connected in forward biasing. That is why in saturation the transistor works as a closed switch, and this is used for switching purposes, mainly for switch on condition. The third and the last operating condition is cutoff, where both the junctions are connected in reverse biasing. This mode of operation is also used for switching purposes, but for switch off condition, because in reverse biasing the transistor works as an open switch. Now this is the time to get the pro tip. There are two symbols. You have to differentiate between these two, which one is PNP and which one is NPN transistor. Now how you will be able to do that? If you look at the symbols properly, you can see that the only difference between these two pictures are, in case of this picture, there is an arrow indicating from the base to the emitter, and in this picture the arrow is in the opposite direction, that is from emitter to base. Always remember that the current flow is from positive to negative, that is from P-type semiconductor to the N-type semiconductor, and this arrows representing the direction of current will always from P to N. That is why this is your NPN transistor and this is your PNP transistor. Hope this tip will help you to differentiate between the two types of transistor just by seeing its symbol. For more such tips and more such tutorials, don't forget to subscribe to our YouTube channel. In the next tutorial, we are going to learn about voltage regulator. Till then, keep learning, be safe, and keep watching Fun Scholar e-learning series. And if you have any doubt, do comment down below and we will definitely try to help you out. Thank you for today.